So let's go through and do number 1 in the practice homework, the practice first exam. Okay, so hopefully you've seen another copy of the exam, or you have printed out one or something. You can download it from Blackboard. So here's the first question. It says, state the domain and range for each of the functions plotted below. Also state the intervals of increase, decrease, and whether the function is 1 to 1. So there are 3 parts to this question, A, B, C. So let me just start here on A. Alright, so first let's do the domain. So remember, the domain of a function is the set of x values that make sense to put in. And you can figure those out just by pushing it down onto the x-axis and see which intervals on the x-axis make some kind of curve come out. Okay, so the domain includes this little red part that I've just done, and sorry, my vertical line is a little sloppy, and this other part. So these are the only intervals on the x-axis for which this function is defined, and so that is exactly the domain. So what we need to do now is just somehow express this red stuff that I've just drawn in interval notation. So the domain, I'm just going to make kind of a reasonable guess about what this might be. So let's say that this looks something like negative 2.2. I think that's what it's supposed to be. And then this is something like minus 1.5. Alright, and so this other part is clearly just negative 1 to positive 1. Alright, so finishing this part of the problem up, the domain for part A is negative 2.2 to negative 1.5, union negative 1 to positive 1. And notice that I've used hard brackets here to define these intervals. It's actually ambiguous from the picture whether this function is defined. So this would mean it was not defined at negative 1, and this would mean that it was defined at positive 1, and that would affect whether these brackets here were soft or hard, but just make reasonable assumptions and ask me on the exam if you're not sure what I mean. But you're welcome just to use hard intervals when in doubt. Alright, so what else do we need to do? We need to find the range, right? So to find the range, instead of pushing onto the x-axis, you just push onto the y-axis. So let me see, it's not giving me a very good line. This thing recognizes lines, but only if you can draw something that is approximately straight, which I have a hard time with apparently. Okay, alright, okay. So this is part of the range, and also this is part of the range. So see, what I'm doing in green is just pushing the function onto the y-axis. So the fancy word is projecting. I'm projecting the graph down onto the y-axis. So this green stuff is the range, right? So the range of this function is, it goes from 0 to 1, and I'm going to go ahead and use the hard brackets. And it also goes from, this looks like about, I think this is 1.5 to 2. So 1.5 to 2 is also in the range. Alright, so now we've got the domain and the range, and we want to do the intervals of increase and decrease. Okay, alright, so mostly it's decreasing. Let's do decrease first. Maybe I should change colors, because this green is probably hard to see. I'm going to switch to magenta. So that says decreasing. I hope you can see it on your computer screen. You know, on YouTube you have the option to do full screen view, so maybe you want to do that. Alright, so where is it decreasing? It's decreasing on this stuff. So over here it's decreasing, right? That part is decreasing. So part of the intervals where it's decreasing is the interval from negative 2.2 to negative 1.5. Okay, and where else? It's also decreasing here. So it's decreasing from negative 1 to 0. Negative 1 to 0. Okay, and this other part is the only part where it's increasing. So it's increasing here, right? It means it's getting steeper, or the tangent line is positive slope is one way to think of it. Okay, so let's say that it's increasing. It's increasing on the interval from 0 to 1. Alright, and that's the answer to 1a. 1a is completely done. So let's shift over here and figure out 1b. Okay, so maybe we don't have to do all the detail. So let's just go through this one a little faster. So it's the domain. Okay, so the domain looks like something like negative 2.2 again, to something like negative 1.5. So negative 2 to negative 1.5. And it's also defined here from negative 1 to positive 1. Negative 1 to positive 1. Okay, and then I am going to assume that it's not defined exactly at 1. It looks like, well, you can't tell from the picture, but it makes it simpler. So I'm going to assume that the function is not defined exactly at 1. And, oh geez. So it's erasing everything except for this terrible line that I just accidentally drew. Okay. So it's defined from negative 1 to positive 1, and I'm going to use a soft interval here at positive 1 just because it makes things easier. So negative 1 to 1 soft, okay? And then we'll assume that it picks up again over here on this other part that has a vertical asymptote at 1. And so it's also defined from 1 soft over to positive infinity via this part. Okay. Alright, so that's the domain. Let's do the range. Alright, the range is easy, alright, because this part, this long thing, if we push that over onto the y-axis, it's just going to hit absolutely everything, right? So that makes it easy. The range of this function is just r. So that's the same thing as the interval from negative infinity to positive infinity. And we need to know increasing, decreasing. So let's do decreasing. So this little part is pretty clearly decreasing, so we'll put in the interval from negative 2 to negative 1.5. Alright. And it's also decreasing nowhere else. That's it, actually. See, that's the only part where it's going down. And now where is it increasing? Okay, well, everywhere else. So I'll just put the rest of the domain here. It's increasing from negative 1 to 1, and then also from 1 to infinity. Alright. So if you think about that, something kind of, we could talk a little bit about what happens there at 1. You know, it's a little bit subtle, especially if you assume that it's defined at 1 via this point. So ask me about that if you want, but that's a perfectly good answer. Alright, and let's finish up with C, which will hopefully be very easy. So for C, the domain, you can see that it's going to be from negative 1 to 1, and then together with something like 1.5 to, that looks to me like, what is that, like 2.2 or something, so let's call it 2.2. Alright, and what about the range? So we're pushing it over onto the y-axis, and that's pretty easy. That's just the stuff from 0 to 1. Oh, sorry, 0 to negative 1, and so I should put the smaller number on the left, right? Okay, so it's from negative 1 to 0. Okay, and now where is it increasing? It's increasing from negative 1 to 0. And where is it decreasing? It's decreasing over here from 0 to positive 1. And this little bit here is also decreasing from 1.5 to 2.2. Great. Okay. And now I just remembered that I forgot to say whether these are one-to-one or not, right? That was part of the question. We have to say whether the function is one-to-one. So to do that, we just use the horizontal line test. So I'm going to use yellow, the worst color of all. And so let's do the horizontal line test here. Clearly, if I draw a horizontal line like that, I can hit that function twice, right? I hit the graph twice. So it fails the horizontal line test, and that means that this thing is not one-to-one. Okay, and what about this other thing over here? Kind of same story. I can draw this horizontal line, and it hits the function there, but it also hits it here. So this thing fails the horizontal line test too, so it's not one-to-one. And let's do this last part. So for this last part, part C, it clearly also fails the horizontal line test. Horizontal line hits the graph of the function there, and it also hits the graph of the function there. So this is not one-to-one. Okay, great. So that finishes up problem 1.